Okay, so if everybody would go to page 13 in your packet, at the top of the page it says exercise 2, the meaning of limits. I want to take a look at number 5, 6, 7, and 8. I know the number doesn't look like it, but that's a 5 up here. Okay, so there we go. All right, so this is what the question's asking for. It's asking for what's the limit of f of x as x approaches 1. Now what I did over here, and you can take my word for it, I mean if you want you can figure this out, but you've got a line, you've got another line here, and we've got a square root. So what I did was I did a rough sketch over here of what f of x looks like. All right, so if you look at the original question, it's saying as x approaches 1. Well, we can go over and we can look at the graph. Here's x equals 1, and if we follow it up, you can see that the limit coming from the left-hand side, that would be coming from this direction, would equal the limit coming from the right-hand side. If we look at this portion here of the graph. Now this is easy to see when you have a picture, and what I'm trying to get at is it's going to be ridiculous for you to draw a picture every single time. So, whoops. So anyway, so if you look at this, again, it's pretty easy to see that the limit's going to exist. We're going to look at this section of the graph, and then basically we need to determine what the value is when x is equal to 1. So let's go over and look at the actual equation here. Now we have a piecewise function. The easiest way to do this is to look at your domain. So we have a domain here, but if you look at this domain, it does not include x equals 1. And if you look at this domain over here, this is x is greater than 3, that also does not include x equals 1. So if we look at this domain right in here in the middle, we do see that 1 is in between a -1 and a 3. Thus, when we're trying to figure out what the limit is as x approaches 1, we're going to look at this part of the piecewise function, which, by the way, corresponds to this graph right here. So the easy way to do this when we don't have a graph is to look at your domain and see which of the 3 domains will include x equals 1, which is this one right here. Okay. So then what we do from there is we're going to look at this part of the piecewise function right here, and we're going to plug in 1. So basically we're going to do 5 minus 1, which equals 4. And there's your answer. Not so bad, right? All right, so now we're going to try to do this one without a picture, because doing a picture every single time is annoying. So we're going to try to do the same thing that we did on the last one. So we're going to look here and we're going to say, okay, as x approaches 1. So let me see if I can find x equals 1 in either of these domains here. But look at what happens. This is when x is less than 1, and this one is when x is greater than 1. So neither of these domains actually contain this value, x equals 1. Okay, so let's just hold on a second. So what we're going to do is we are going to try plugging in 1 into the top. So we'll get 1 plus 3, which is 4. And let's plug in 1 into the bottom. So we're going to get 1 plus 15, which is 16, but then the square root of that is also 4. So you should see that these two match. Okay? So basically what that means is the limit coming from the left-hand side here, okay, so these values are less than 1, so coming from the left-hand side of 1 is equal to the limit coming from the right-hand side when these numbers are greater than 1. So when the numbers are less than 1, we get a value of 4. When the numbers are greater than 1, we also get a value of 4. So not that I'm going to even remotely sketch an accurate graph, but if I were drawing a picture, basically, I'm just going to make something totally up like this. Basically, that's what it means. That the limit coming from the left-hand side here will equal the limit coming from the right-hand side. It just means we're going to have a hole here because we don't have an actual value of 1 included in either of these domains. Okay? So, going back to it then, our answer here would just be 4. All right, so let's look at number 7. Now, number 7 is asking two things. So I'm just going to start by looking at this limit of h of x as x approaches 1. So again, I'm going to try to look for 1 in either of these domains. Now, I do see it here, but look, this is saying when x is equal to 1, y is equal to radical pi. Now think about what pi is. Pi is 3.14, blah, 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 blah. So if you take the square root of that, that's a number. So this is saying when x is equal to 1, y is equal to radical pi. That's a point. That's what this is saying, is that we have a point x, comma, y. Okay? Which is not an interval like it was in number 5. Go back and look at number 5. The 5 minus x part of that piecewise function, look at the domain. 1 was inside that interval. This is not an interval. This is one x value. So what we're going to do for number 7 to determine what the limit is we're going to look at it just like we did number 6. So this would be the limit coming from the left because these values are less than 1. And this is going to be the limit coming from the right because these values are greater than 1. All right, so in that case, all we're going to do is we're going to do what we did in the last one. So we're going to plug in 1 up here. So we're going to get 1 plus 3, which is 4. And then we're going to plug in 1 down here, and we're going to get 1 plus 15 underneath that square root. And again, that's also 4. So since these match up, then the limit of h of x as x approaches 1 is 4. Okay? Now let's look at the second part. This second part here is specifically asking, when x is 1, what is y? Okay? When x is 1, what is y? So let's go down and look. Well, look. Here's where x is 1. What's y? Ding, 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 ding. Okay? So your answer would be radical pi. All right, let's look at the last one, number 8. So we're back to just, they're asking one question, and that's the limit of the function f of x as x approaches 1. So let's start, again, let's start here and see if we can find 1 in an interval in any of these 3 domains. Well, it's not here. Ooh, it is in here. Do you see that 1 is between these 2? So this is going to be like number 5. Because 1 is in an interval, then all we need to do is look at this part of the piecewise function and plug in 1 right there. Okay, so really simple. So all we're going to do then is we're going to do 1 minus 5, and we know that that is going to be negative 4. Done. Okay? All right, so now that you're done with 5 through 8, if you don't understand it, please go back and replay the video. Make sure that you truly understand it. If not, I'll be seeing you for X time next week. But your classwork homework, if you don't finish it by the end of the period, you're going to be doing pages 10 through 13. Obviously, we did 5 through 8 on page 13, so you're going to finish the rest of page 13. Okay, so pages